At this point, the story stops being about China in any narrow sense and starts becoming about what modern power actually is when you strip away the traditional language we still use to describe it. We keep reaching for old categories: military versus civilian, war versus peace, medicine versus defense, industry versus intelligence. But biotechnology doesn't respect those divisions. It leaks through them, quietly, systematically, until the categories themselves start to feel like outdated filing cabinets we inherited from a different century. And that is where the real shift sits. Because if you track China's military medical research, its dual-use biotech funding, its genomic infrastructure build-out, and its integration of AI into biological modeling, you eventually hit a point where asking, "Is this military or civilian?" becomes less useful than asking something else entirely. How quickly can biological capability be converted into national advantage when needed? That is a systems question, not a policy question, and systems behave differently than intentions. One of the most revealing trends is how often Chinese defense-linked biomedical literature returns to endurance rather than transformation. Not enhancement in the cinematic sense, but stability under strain. How long can a human operator remain cognitively functional in high-stress environments? How quickly can recovery cycles be shortened after exposure to fatigue? How can biological variability across large populations be modeled and managed in real time? These are not exotic questions. They are logistical questions reframed through biology. But logistics is where wars are actually won. In that sense, biotechnology does not replace traditional military power. It quietly sits underneath it and changes the assumptions everything else depends on. Aircraft, satellites, drones, and cyber systems all rely on human networks that still fatigue, recover, get sick, make errors, and break under sustained pressure. If you can improve that layer even slightly at scale, you change the performance envelope of every other system built on top of it. That is why some analysts in the United States Department of Defense have started describing biotechnology as enabling infrastructure for multi-domain operations. It sounds abstract, but it reflects a growing realization. Future competition is not just about platforms, but about the biological systems that operate those platforms. China's advantage, where it exists, is not necessarily in any single breakthrough. It is in the density of connections between institutions. Military hospitals, civilian research labs, provincial biotech zones, pharmaceutical manufacturers, and AI companies operate in overlapping ecosystems. The boundaries are not fully erased, but they are more permeable than in many Western systems. That permeability increases speed, but it also increases opacity, which brings us back to the core tension running through all of this. Western observers often assume that if a capability were operational at scale, it would be visible in obvious ways. Deployed systems, official announcements, clear indicators of readiness. But biological capability does not announce itself like a weapon system. It accumulates in databases, protocols, manufacturing pipelines, and training models. It becomes visible only indirectly, usually through procurement language or research patterns that only make sense when viewed across time. This is why that Xi'an hospital procurement notice mattered earlier. Not because it proved a dramatic breakthrough, but because it signaled normalization. The language of adaptation, endurance, and biological optimization appearing inside routine military medical infrastructure suggests that the conceptual shift is no longer theoretical. It has entered operational vocabulary. Now, there is an important counterpoint here that should not be ignored. China's biotechnology ecosystem is not frictionless. Far from it. There are serious issues with reproducibility in some research sectors. Local government incentives sometimes inflate performance claims. Regulatory inconsistencies exist between provinces. And despite massive sequencing capacity, turning data into reliable therapeutic or military-grade application is still a global bottleneck, not just a Chinese one. In other words, capability does not equal mastery, not yet. The United States still holds significant advantages in foundational biomedical innovation, high-end clinical research, and early-stage biotech startups. Europe maintains strong regulatory science and pharmaceutical expertise. Global biotech is still deeply interconnected, and no single country dominates the entire pipeline from discovery to deployment. But pipelines are not static. They evolve under pressure, and pressure in this domain is increasing from multiple directions at once: demographic change, pandemics, AI acceleration, and geopolitical fragmentation of supply chains. Each of these forces pushes biotechnology further into strategic territory, whether policymakers explicitly want it there or not. Which leaves us with an uncomfortable conclusion forming in the background of all this analysis. The question is no longer whether biotechnology will become part of military competition. It already has. The question is whether states understand what it means to compete in a domain where the line between human biology and national infrastructure is starting to dissolve.